With this video, we begin our new series on data structures. Remember that all elements of R are objects. Everything that exists in R is an object. So not all objects are data structures. For example, functions and operators, which are special types of functions, are not data structures. They are for initiating a function call, which will perform some action on an object. But many of the objects in R are data structures. Any object that will contain data is a data structure. We have already looked at the main classes of data structures in R, but now we're going to take a deeper dive. We're going to learn more about the objects. And we need to take this deeper dive if we're going to be able to write good, efficient, working scripts to do anything we want them to do in R. So let's begin. And naturally enough, we're going to begin with vectors. That's a good starting point because vectors are the basic data structures of R. Remember that vectors have a virtual class type in R, so when you ask for the class of a vector, you get either logical, numeric, which would contain both integer and double data, and character. Now, because vectors are the basis of all data structures in R, every other data structure is composed of vectors. Matrices are columns of vectors. Arrays are matrices of vectors. Factors are vectors of integers with character names. Lists are columns of vectors of differing types. And finally, data frames are columns of vectors of differing types, but with equal length, which is why a data frame is a special case of a list. Now let's look at creating a vector. I encourage you to follow along with me as I work through my R Vectors notebook to exemplify vector creation, subsetting, and other aspects of working with vectors. It's always good practice to load any libraries that you're going to use at the beginning of the notebook, so I'm going to use the Here library, even though I'm not going to use it until later on in the notebook. So the vector is the basic data unit in R, and here we're going to explore working with vectors in scripts. Let's start with creating vectors. With the exception of scalars, all vector creation requires concatenation. Now, some functions actually concatenate implicitly. It's behind the scenes, you don't see it, and you don't need to worry about it. Here's a scalar. A scalar is simply a vector of length 1. So when I look at my scalar here that I've created, you can see it's just 13, and if I were to obtain the length of my scalar, it's just length 1. So that's just the definition of a scalar. In R, it's a vector of length 1. In mathematics, we refer to a scalar as a single number. But in R, the vector is as low as you go. It's the base unit. It's like the letter in any spoken or written language. Here I'm combining scalars to create a vector with length greater than 1, my vector. And so my vector, which we can see here in the environment, was created. And this vector, of course, has a length that's equal to the number of elements of that vector, 7. This creates a numerical sequence. We've seen this before with the sequence operator when we discussed it. The colon is the sequence operator. So here I have my sequential vector that's 10, 11, 12, 13, all the way to 17. Now here's a more complex sequence, and we're using a function that's very useful for creating certain types of vectors. It's the sequence function. This sequence function asks us to create a vector from 2 to 6, but to do it in increments of 0.1. So if we look what was created here, we see that we have 2.0, 2.1, 2.2, and so on, all the way up to 6.0. If you leave out the by, the assumption will be is that you just want to do it by 1. So if I had done this, sequence 2, 6, and did not put in the by, I have 2, 3, 4, 5, 6, which of course is the same as doing it easier with the colon operator rather than the sequence function. So usually when we run the sequence function, we don't leave the by blank because otherwise we'd be using the colon as the sequence operator. But when we want to do something other than sequences by 1, this is very useful. Let me do one more. Let's do a sequence 2, 6, this time by 0.5. And that shows you again that you can do any step increment that you want. So creating a vector, a scalar is a vector of length 1. Concatenating is the way we combine our scalars to get a longer vector. Sequencing using the sequence operator, the colon, will create vector sequences, and you can create more complex vector sequences with the sequence function. Vectors can be created as the result of operations and functions with vectors. So I've given you the basic ways to create a vector, but you can also do various operations and store those operations, or use various functions and store the result of those functions to also create a vector. That is, anytime you have a function that gives you a vector back, all you have to do is create an object with that name, assign it from the function to that vector, and you have created a new object that is a vector. Let's now look at some characteristics of a vector. The two primary characteristics are type and length. So let's take my vector, which we can see here in my environment, this 7-element vector. And so type is double, which tells us the type of values. Remember that this is a numeric vector. The length is 7 elements in the vector. The type of data in a vector can be logical. It can be numeric, which comes in two flavors, integer and double, or it can be character. And then there is the length of the vector. Pretty simple. The two basic characteristics of a vector. Now let's turn to something that's going to be very important when we write scripts and work with data and do statistical analysis, and that is we need to subset. In other words, we need to pull out one or more specific elements within our vector in order to work with those elements. We can subset by position. So here I have my vector, and I am indicating within the brackets a 3. So the brackets, the square brackets, are actually an operator. They're a function. Remember, operators are specific types of functions. So these two square brackets, let me just isolate them for a moment. So you have a left and a right. Together, they work as an operator, as a particular function. And the function is to select elements. And one way we can select elements that we can subset out is to put in the position of the vector. So if you look at my vector here, 13, 52, 44, 44 is in the third position. So when I subset, I get that 44. Obviously, if we wanted to, we could assign it to an object. Like here, I've assigned it to A. This creates a new object 44. So we can assign any subset to another object and have a subset of the vector in that object. Here I'm going to pull out two elements, the third and the fifth. As always, when we're creating a vector, we need to concatenate. So notice what I'm doing. I'm using a vector to subset a vector. So the third and fifth elements are 44 and 29. Let me demonstrate again a little more explicitly how I'm using a vector to subset a vector. Let me create a vector 3 and 5. So there's my vector B, 3 and 5. I could actually have done this, and it would have subsetted out the third and fifth elements. We can subset by leaving out elements in certain positions using the unary operator, the negative, or that little hyphen. So here I'm saying, give me everything except the fourth element. So if you look at my vector here, the fourth element is 60, and here's what happens when I run it. I get everything out except the 60. Here I'm asking to leave out the fourth and the sixth, which would be the 60 and the 48. And so I'm again using a vector, but this time I'm using a vector to subset to say what to leave out. We can subset by logical reference. So here I'm asking to return to me to subset out everything that exists at the same location as a true in this logical vector. So 1, 2, 3, and let's see, 4, 5, 6. 1, 2, 3, and the sixth elements are the ones I want to get out, and there they are, 13, 52, 44, and over here at the sixth element, 48. We can subset by the names of an element. So let me go ahead and create a vector with named elements. Let's go ahead and look at that so you can see the names. There's the vector with named elements. I can now call on student score, the vector student score, and subset out Martin. So by name, I can pull out that 86. Remember that Martin is not the vector. The vector is numerical. Let's show you that. So type of see, we have double data, not character data. So Martin is the name of the location 80 that has 86 in it. And so that's what we're pulling out here. Let's pull out Ginger and Martin. There they are. We can use subsetting to modify a vector element. So notice here that I am not only taking a vector element. So first of all, let me create the vector, evens vector. Not only am I using the subsetting function to just see what's there, I'm not doing it for that purpose, but rather I'm saying, let's assign a 10 to the fifth place. So right now, if I get evens vector, right now it's 2, 4, 6, 8, 9. Obviously that 9's a mistake if these are supposed to be even numbers. So let's assign a 10 to the fifth place. And that's what we've done right here. And now you can see down here in my environment, the evens vector has been changed to a 10. That example was silly. Let's get rid of the vector. Note that if I do this, evens vector null, that evens vector still exists as an object in my workspace. Here it is. But it's now an empty object. It won't contain anything. So I can use the null, all capital letters, no quotes around them. If I put quotes around them, now it's going to change it to a single word, that vector. So null, in all caps with no quotes, will nullify everything that's in the vector. So let's review what we've seen with subsetting, which we're going to use a lot. Subsetting a vector uses the subsetting function, the square brackets. The integer within the function indicates the position of an element. Subsetting with positive integers will keep elements at those positions, and subsetting with negative integers will drop the elements at those positions. Subsetting with a logical vector keeps the elements corresponding to true, and names of elements can be used to subset.